APs are operating on different channels. And what we've illustrated here is a 3-channel system, which would be typical of most of the systems deployed today, which operate in the 2.4 gigahertz band. There's another band at 5 gigahertz, which actually has more channels than this. But this is the typical configuration, and one of the challenges is that it is constrained in the number of channels. It would be this architecture would work much better if there were more channels, but there are only 3 independent channels. And the strategy in doing this is to make sure that there's enough wireless coverage everywhere, but try to reduce the power of each AP such that it doesn't interfere with another access point operating on the same channel. And that can be challenging. But this is the general architecture. Now what happens is this system does generate interference for itself, but the 802.11 protocol recovers from that, and you don't see it as any kind of catastrophic failure. What you see is the overall system performance coming down. So one thing that's true is certainly in this case we show 7 APs covering a floor of a small office perhaps. In this case you would not be getting 7 times the capacity of a single AP. The system capacity is actually much less than that because of the interaction. Let's go on and talk about the different generations of wireless LANs. The first generation really wasn't really well designed for the enterprise. It was that single AP, and as I mentioned, the standard is kind of mute about what to do when you have multiple APs. There's no coordination of that. So the second generation, which came along, was really combining a standalone wireless LAN with another appliance that would make it easier to manage in the enterprise. And typically that separate appliance dealt with security and also tried to address the management. The next generation, which is really the one that's been in place for quite some time now, created a custom appliance, a wireless LAN controller, and re-architected the APs a little bit, made them simpler and smaller, and moved some of their functionality into the controller. This is the architecture that Airspace employed. Airspace was a company that was eventually purchased by Cisco, and so that's the core of their enterprise wireless product line. Aruba is the same as well. So it's still using that cell planning that we discussed before, but you have a central wireless LAN controller that automates some of the configuration and management of the access points, and also centralizes the security, the authentication and keys and so forth. So this architecture actually was key to Wi-Fi becoming more successful in the enterprise. But still, it was somewhat limiting, and so Extricom came up with the 4th generation architecture, which the fundamental difference, it's really got the same components. There's a central thing. In our case, we call it a wireless switch connected to a bunch of access points. But the fundamental difference is that now the real-time activities of those access points are coordinated by the central switch. And so instead of independent access points doing the best that they can, you now have a coordinated system where the transmissions of all the access points are controlled and coordinated over a much larger area. We call that a channel blanket, a set of access points operating on the same channel and controlled and coordinated by a central switch. So now that central switch does more than management and configuration, upfront deployment, easing the deployment. It also gets involved in the ongoing real-time operation of the network, controlling and limiting, reducing co-channel interference entirely, and also ensuring seamless mobility as stations move from one AP to another. Moving on. So that's the fundamental difference of Extricom, the fact that the central switch is really controlling and coordinating the access point. There's a number of benefits that come from that, and we overcome some of the limitations of these first generations. Really, one of the key things is on the RF side, limiting co-channel interference. Also, our system really addresses mobility. So anywhere within that channel blanket, there's no need for a roam event, or what's called in 802.11 parlance a BSS transition. That is, in the microcellular architecture, at any point in time, a mobile client is associated with one and only one access point. That is the required operation in order for it to work properly and to avoid loops in the network, for instance. In the Extricom case, that mobile client is not associated to a particular access point, but rather to the central switch, and it's essentially associated with all of the APs all the time. And so there's no need to transition from one to another as a mobile client moves beyond the boundary of one AP and into another. So let's go into more detail on the Extricom difference. As I mentioned, we have this thing called the channel blanket. All of the APs in a given area are organized on the same channel. They're connected to a central switch, and that set of APs is called the channel blanket. Our current product line supports channel blankets up to 32 APs large, and then each of those access points is actually different than a conventional AP. It can support up to it has 4 radios in the best case, and can support up to 4 layers. We have 3 and 4 radio APs that are appropriate for deployment in the enterprise and can be controlled by our switches. So one way to think about this is the entire channel blanket is acting as if it's a single AP, and the clients enjoy the benefit of that simplicity, much like that very first slide that I started talking about, where there was just a single access point. And it results in a very robust system and a very high-performance system. A key benefit is kind of illustrated in that picture at the top. In the lower left, there's a mobile client, and we're indicating that it can communicate with more than one AP, and that it's shown speaking to four APs. Why is that? Well, certainly, first of all, they're all in the same channel. So every time that wireless client is transmitting, that central switch is going to hear multiple copies, and understanding the received signal strength and other parameters, it knows which of those APs has the best link, has the best communication with that mobile client. And then for transmissions, it uses that same AP back to the client. And of course, that's changing dynamically on a packet-by-packet basis. So it's constantly, the link between the mobile client and the wireless LAN infrastructure is constantly being optimized in our case. As I said, in a microcellular system, that wireless client is associated with one and only one AP, and so you only have one link. We have multiple links to draw from. It gives you this extra system-level diversity, which results in a very robust system. So one of the benefits, one of the virtues of the Extricom system is that it works well in harsh environments. Let's go on. So we talked about a channel blanket. What happens if you want to put more capacity in the same area? Well, by using the multi-radio APs that we have, we can layer in multiple blankets, each of them operating on a different channel. Those different channels are separated in an RF sense and isolated and operate independently. And so in our case, we can have up to 4 blankets. What we're showing here is 3 blankets that are active for data, one for voice, one for data, another one for, well, it looks like an iPad with a stylus, and then another one which is doing security, rogue access point detection. You can configure them however you want, though. You could have all of them. You could have 2 operating in the 2.4 band, 2 operating in the 5 gig band. You can have 1 for voice, 1 for data. You can also have some blankets dedicated to a particular application. Or maybe you put all your legacy clients on one blanket, all your new shiny 802.11n clients on another blanket. So it's really a multiple networks in one, and you have this multi-layered system, which gives you additional capacity, but also you can do this organization of the network to optimize its performance. And to win back even more capacity, we have something called true reuse, which because the central switch is aware of the environment, it can understand that maybe it's possible to